So we're going on to Unit 5A, Lesson 1. Sorry, you can probably hear my dog who decides to eat in the background right now. And it could have been in Unit 5, but we did enough with the trig. It's still staying on the trig, but we're taking it just a little further. You're going to be learning about the reciprocal functions. So here we have the definition of reciprocal. Mathematically, it's a function that's related to another so that their product is 1 when multiplied. The quantity obtained by dividing a number by a given number and getting a quantity of 1. So for the most part, you've always heard reciprocal means to flip. Like if I asked you what the reciprocal of 8 was, you would just say, oh, 1 over 8. Well, the reason we flip it is because if you multiplied 8 by 1 over 8, you get that famous number 1. So I don't know if you ever thought about it, but last year or 2 years ago, or whenever you learned CCA2, did you ever wonder why it was always opposite over hypotenuse? Well, hopefully trig answered that, but did you ever realize, well, how about if I wanted to do hypotenuse over opposite? Or hypotenuse over adjacent? Or let's be daring and do adjacent over opposite. You can, because those are the reciprocal functions we're going to learn about. Sine, its reciprocal is 1 over sine, and we have a name for 1 over sine. It's called cosecant, and it's abbreviated as such. Cosine, obviously reciprocal, 1 over cosine. Its reciprocal is called secant, and it's abbreviated as SEC. And our last friend, tangent, 1 over tangent, is called cotangent, and it's abbreviated as cotangent of theta. So just remember, these are all the reciprocals. So cosecant is really hypotenuse over opposite. Secant is really hypotenuse over the adjacent side, and cotangent is really adjacent over opposite. So these reciprocal functions also have graphs. And this is what they would look like. So the first one we're going to look at here is the sine in the cosecant wave. So you can see here that we have our sine wave here in red. Make that a little bold so it sticks out. It's the best I can do. And reciprocal means to flip. So if we started with the easiest number to flip, that would be 1 right here. When I flip 1, remember the sine of pi over 2 is 1. So when I flip 1, that also means the cosecant of pi over 2 is 1. But notice here, the cosecant wave is a pink U. Think about it. If a sine is a hill followed by a valley, when we flip it, it'd be a valley followed by a hill. And that's exactly what happens here. Really, the mathematical is this. This number right here is so small because we're getting closer and closer to 0, right? Where the sine of pi is 0. Since we're approaching 0 and we're getting into a very, very, very small number, then when we flip a very, very small number, we get a very, very big number. And these are our friends, the asymptotes. Because remember, you can't flip 0. So the cosecant of pi would be 0 flipped, which would be 1 over 0, and that is impossible to do. It's undefined. So wherever the sine wave hits 0, the cosecant wave is now undefined. And in fact, that's how I would draw the cosecant wave if I was asked to draw it. Let me demonstrate. Let me clean this up. All right, so if I asked you to draw a cosecant wave, first thing I would do is I would give myself my boundaries. Pi over 2, pi, 3 pi over 2, and 2 pi. And then in my head, I would think about a sine wave. So a sine wave is a hill followed by a valley. There's my hill, there's my valley. And then I would give myself my asymptotes because I would say, self, wherever it hits 0, you have to be undefined. And then I would just look in each little quadrant and say, well, reciprocal means to flip. This is a hill. When I flip a hill, it must become a valley. I know they're going to touch at 1, and look at that. There's my valley. Oh, look, here's my valley. Well, -1 flipped is -1. Oh, and here's my hill. And that's how easy it is to draw a cosecant wave. So a cosine wave and a secant wave are the same. Philosophy, as a sine and a cosecant wave. So in other words, I'm going to give myself my boundaries, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to think, what does a cosine wave looks like? Well, a cosine wave is a big C. It starts high, it ends high, and directly in the middle it hits its low. It's really a little far off from 2 pi, but you get the idea. And then wherever there's a 0, same thing's going to happen. You can't take the reciprocal of 0. You get an undefined. So now I'm going to take the reciprocal of my cosine wave, and well, here's that -1 they share again, and this is in between these two undefines is a valley. So when I flip a valley, I get a hill. And right here we have half a hill. So when I flip half a hill, I get half a valley. And once again, here we have another half a hill. So I get half a valley. Remember that when I have really, really small numbers, they flip and become very, very big numbers. What gets to be a little confusing is our friend, the tangent wave. All right, so we haven't really studied the tangent wave that much. The new Common Core doesn't want us to look at it, but I still think it's a nice wave. So we know that the tangent wave already has asymptotes built into it. It's right here at 90 and at 270. And we know that the tangent wave looks like such. It approaches 90, but it never touches it. It approaches 270, but never touches it. So that's what the tangent wave looks like. So now the cotangent wave, things can get a little crazy. Here is a little preview of what a cotangent wave looks like. Now here it's backwards. They drew the tangent wave in purple, and they drew the cotangent in blue. What? Kind of looks like water fountain, water spitting out. All right, so let's come back up here and see if we can mimic that. Well, remember that wherever the sine or the cosine wave hit 0, their reciprocal functions were undefined. So that means the same thing's going to happen here. We're going to have undefines right here at 180, 270, and 0. That's a lot of asymptotes going on there. I'm going to just move this off of 0 so you can just see that it stands out. So that means I approach these, but I can't go near them. But whoa, whoa. Remember here? This is where the tangent wave was 0. Sorry, was undefined. My bad, because I'm getting ahead of myself. Well, undefined means it was 1 over 0, and if I flip 1 over 0, it becomes 0 over 1. So that means the cotangent wave is actually defined where the tangent wave is not defined. Wow. So that is why our friend, the cotangent wave, is going to look like this. Wherever tangent was undefined, cotangent is defined. And remember, wherever the tangent wave was getting very big, the cotangent wave was getting very small because we're taking the reciprocal of it. That's why they have a reversed mirror image of each other. All right, so I wanted to show you what the waves are like, but it's really easy for what you're going to have to do. They're going to ask you to find the secant, cosecant, and cotangent of numbers you already know. So this is all I do. Find the secant of pi over 6. Well, in my mind, there's my mind, I just think, what is the cosine of pi over 6? Well, the cosine of pi over 6 is radical 3 over 2. But I don't want the cosine. I want its reciprocal, the secant. So it's really flipped to 2 over radical 3, which I can then rationalize, which gets me 2 radical 3 over 3. Simple. What is the cosecant of 2 pi over 3? Well, again, here's my big brain. This time it's in blue. I'm kind of winking at you. Haha. And what is the sine of 2 pi over 3? Well, that's the sine of 120. So the sine of 120 is the same as the sine of 60. Oh my gosh, it's radical 3 over 2 again. But then we flip it. And my final answer is 2 radical 3 over 3. All right, what's the cotangent of 5 pi over 4? Well, there's my big brain again. And I think, what is the tangent of 5 pi over 4? Well, pi over 4 is 45 degrees. And the tangent of any 45 degree is sine over cosine. So that's radical 2 over 2 over radical 2 over 2, which, oh my gosh, this is so easy, which is 1. So then I flip that, and I get 1. And the last thing I have to do here is just make sure that I'm in the right quadrant. So 5 pi over 4, 1, 2, 3, 4, 5. Oh, I'm in the third quadrant, and in the third quadrant, tangent, therefore cotangent, is positive 1. And the last thing they could do is just ask you to find all of the trig values. So here we have the sine of some angle is negative 3 pi over 2, and we're in the fourth quadrant. So before all that, I'm going to give myself a fourth quadrant angle. They said the sine, which would be the opposite over the hypotenuse, which means this is 1. Now, what do they want me to do? Find the 5 remaining trig values? Oh, that's pretty easy to do. Well, they already told me sine is negative radical 3 over 2. I almost look like this, like conjugating verbs. Remember when you conjugate verbs in foreign language, like I took French, so it goes je, tu, il, elle, and then it goes nous, vous, il, elle. I do the same thing right here. This is cosine, this is tangent, and then over here, this would be cosecant, this is secant, and then this is cotangent. Well, sine flips to get cosecant. So this is 2 over radical 3 negative. Cosine would be 1 over 2, flips to get 2 for secant. Tangent, opposite over adjacent, would be negative radical 3. Cotangent is the flip of that, which would be 1 over negative radical 3. And then we can rationalize. And we're still in that gray area where we see in Algebra 2, Common Core, sometimes they want us to rationalize and sometimes they don't want us to rationalize. So if you did rationalize these, it's very easy. And we'll try and get you a definite on whether you should be rationalizing or not.